Good morning, everybody. It's Alex St. John here in the Playcast Dungeon. It's 4:17 in the morning, and my eyes are too burned out to code anymore. I'm sitting here. I've even got a crash bug on my screen I can't look at, but I don't want to lose the place in the code to crash, so I'm just leaving it here. But it's going to bother me while I'm talking, so I'm taking a break. I do these streams when I'm procrastinating. You know what's on my mind this evening? Well, one, I wanted to do another STS, the Steal the Show demo. We're building a server down here, but we've got to order a bunch of parts, and, Amazon's taking, more than 30 seconds to deliver them, which is very inconvenient. So the new host, the big rack we're going to mount the monitor on, a lot of the equipment hasn't quite arrived yet. So, in the meantime, I figured I'd tell a couple old-timey stories. And you know what's on my mind is that Nvidia has been in the news a lot lately because they kind of went crazy in the stock market. They've gone through the roof. They're hit like a become the most valuable company on earth for a minute in history, and, bouncing around because people don't know what to make of that. And so one of the interesting things that comes up is you've got all these news stories about Nvidia told by modern journalists. And it's not that they're inaccurate, it's just that they're bullshit. It's really quite odd watching some of them. So, history is written by people who weren't there. And so it's not like they're not saying factual things. It's just that they kind of miss the story. They miss some of the most important elements of it, which I understand because, there were actually very few people there for the big parts of the story. And in fact, there was, let me see if I find it here. I'll link the article. I was watching one particular documentary that I liked because it included some of the DirectX stuff, and some of the video I had produced with Bill Gates to launch Doom was in it. And so somebody knew their stuff a bit there, had tried to do their homework. But the thing that was weird about the history of Nvidia and DirectX is there weren't a lot of people there. There weren't a lot of people involved in the early days. Making Windows a gaming operating system wasn't a big corporate strategic initiative that everybody planned. It was a few of us crazy people going, we're just going to do it. So we were the only ones there. And it's been a lot of years since then, so it's really weird still being around 30 years later and seeing all this media about something I was there for. Nobody talked to me about it for some reason, but they just sort of go on with great authority about stuff that didn't happen that way. And it's quite entertaining. So here's my claim to credibility on the subject. There is my Microsoft Ship It Award. And so WinG was the precursor for DirectX. This was the very first thing we did as an attempt to get Windows 3.1 to be, sufficiently good at gaming. And the very first DirectX 1, 2, and 3 Ship It Awards. Ship It logos. So those are the first ones ever. And here, I'll just minimize this and put it down here. So that is my Microsoft Ship It Award. The funny thing is, I have a lot of friends who have so many more things on their Microsoft Ship It Award, but I was actually in a marketing strategy organization, so by rights I shouldn't have gotten any of these, or I shouldn't have gotten any Ship It Awards at Microsoft because I wasn't supposed to be coding, but I did, and made these technologies. So this is DirectX, this is WinG, which was the precursor to DirectX, plus DirectX 1, 2, and 3. And why is this important? Because DirectX 1, 2, and 3 were made by myself and a couple friends and contractors I put on the Microsoft credit card. And interestingly, we had some strange partners. One of those partners I think I've mentioned before was ATI. ATI had a guy named Ken Nicholson. So, the smart companies who made graphics chips that were specifically Windows accelerators back then, they had the good sense to have a close relationship with Microsoft. So they often had account managers stationed at Microsoft headquarters who were there to, have lunch with everybody. And ATI back then was pretty small. They were known as being a gaming graphics card. They made the Mach 64 back then, which was one of the cooler Windows accelerators, but it was also really good for DOS gaming. And ATI was frustrated because their chips had some really advanced graphics capabilities that just nothing used. They couldn't talk game developers into using it. Windows didn't need it for, rendering Windows. And the DOS developers wouldn't customize for it, but they tried. And so Ken Nicholson, when we started making DirectX and word got around that we were working on trying to make Windows graphics much more advanced, Ken Nicholson got behind us, and he arranged for ATI engineers and contractors to help us make DirectX on the side. He knew it was a Skunkworks project, and we weren't executives. We didn't have permission to do it. So one of the things that was fascinating to me about the history of DirectX is that ATI had an employee account manager who kind of took a flyer with his career and said, even though I'm supposed to work with all these executives and so forth, I'm sitting here doing nothing, and I want to achieve something. And these crazy guys are actually going to try to make graphics work, so I'm going to help them. So we had, when nobody else helped us or cared about DirectX, we had ATI helping us in the earliest days with engineers and code and driver support. And so the early close relationship with ATI had a lot to do with DirectX's early success and ATI's later dominance in gaming graphics. And this is important because when we get to the Nvidia story, one of the things that drives me crazy is that because Nvidia's hit this $3 trillion valuation, and Nvidia got very burned by Microsoft early on, for better or worse, and they learned and they wised up and they learned a lot from Microsoft. And one of the things they learned was great PR. So you have this great revisionist story about how they created the first GPUs. And it's not true. There's people like to have semantics about what the GPUs were back then. But if we talk about the first consumer gaming GPUs, Nvidia and ATI were hand in hand with those early on. And there was a specific reason they were hand in hand on them. So I have the DirectX 1, 2, and 3. See those SDKs and WinG. I should find I have a picture. Let me see if I got another icon for you. Well, I'll find it in a minute. I have an original Windows game SDK. That's the very first, second plate on the Ship It Award. For the very first, it was called the Game SDK before it was DirectX. So I had a picture of that disk around here somewhere. But anyway, so DirectX 1 didn't have 3D support. But we believed very strongly that it was a really important component to add to it, and was very far removed from where Microsoft was at, except over in the Windows NT organization, which, as I've documented before, had a secret deal with SGI to move SGI to Windows NT and OpenGL with it. And so Microsoft had a license and a close partnership with SGI to take control of OpenGL and make it a Windows API for CAD and movie making. And was considered by Microsoft distantly far removed from any interest in consumer PCs and consumer gaming. So when the DirectX team, we said we want to make Direct3D, and I went out and led the effort to acquire, along with Craig Eisler and Eric Engstrom, the two guys I created DirectX with, we went out and led the effort to acquire RenderMorphics, a British company, 3D company. And we brought them, relocated this English team to the U.S. Kate Seekings, president of the company, came to work for me as Microsoft's first Direct3D evangelist, and promoting it. And again, I like to drop her name a lot just because she's interestingly forgotten in the history books, and yet she was the one who sold a 3D standard for gaming to Microsoft and started this all off. And Servan Kajian, of course, who was kind of the chief mind behind the engine. And he was quite visionary about wanting to create a market for 3D consumer hardware for gaming. So one of the reasons that we chose to acquire them is that unlike other 3D game engine companies, they'd done a lot of work at RenderMorphics and given a lot of thought to how they would create drivers for 3D graphics and would support it. And Servan was quite advanced in his thinking about how to enable 3D graphics. So remember that DirectX 2 shipped in beta in early 1996, okay? 96. And this is so I have the original SDKs here. I share them every once in a while for people who want to look at these kind of historical bits. So I have here the original written in 1995 by me and Kate, documentation that's on the DirectX 2 SDK, where the beta for Direct 3D, the very first version of it, was shipped with DirectX 2, was released. And I'm going to read you a little clip from it here, but I brought just the relevant part. Well, I'll read it and then we'll tell you, okay? I'll show you the snippet. Let me move. Whoops. I mean, not that part. I want to move. Let me see here. Pardon my OpenGL pertese here. I'll move that over there. All right. Here's what the original documentation for Direct3D reads. A future release of OpenGL will be able to take advantage of lower-priced 3D hardware, provided that it supports the precision conformance requirements of OpenGL through the Direct3D API, providing a hardware solution that complements Direct3D architecture. The Direct3D vision is designed to enable world-class game and interactive 3D graphics on a computer running Windows. Its mission is to provide device-dependent access to 3D video display hardware in a device-independent manner. The application does not need to implement the specific calling procedures required to draw texture-mapped, perspective-corrected, or alpha-blended 3D primitives on a particular piece of hardware. Simply put, Direct3D is a drawing interface for 3D hardware. Now, this is important because a lot of the OpenGL Direct3D war nonsense, it was obviously very kind of ideologically driven because Direct3D was just Microsoft's driver standard for a Microsoft proprietary OS. Microsoft's not an open source company. It's totally closed. And if you wanted to make drivers to support the operating systems to support 3D graphics, only Microsoft could create driver architectures that Microsoft would support or that OEMs would ship. So even though Microsoft had essentially taken control of OpenGL on the sly back then, and had a lot of influence over it, even OpenGL would still need to in order to run in Windows, needed a driver model that was going to be proprietary to Microsoft. And that's what Direct3D was Microsoft's Windows hardware driver model. So Direct3D wasn't an API like OpenGL. Wasn't meant to be used. It was much lower level. It didn't have all the high-level functionality and render pipeline that OpenGL did. And yet people sort of conflated the two, which was quite odd because OpenGL was always meant to really be a layer above somebody's proprietary operating system hardware and driver layer, unless, Linux came along and you had an open source one as well. So OpenGL isn't a driver model for anything. You had to make that separate from the API. But here's where it gets interesting. Simply put, Direct3D is a drawing interface for 3D hardware. Now wait for it. 1996, February launch, beta SDK. Here's the doc for Direct3D. It integrates tightly with DirectDraw as its buffer management system, allowing DirectDraw surfaces to be used both as 3D rendering targets and as source texture maps. This was a big idea because it also included standardization for Z buffers, which was crazy. This allows for hardware decomposed motion video mapping, hardware 3D rendering in 2D overlay planes, or even sprites. For example, Direct3D is designed to set a standard for hardware acceleration, including geometry, transformations, 3D clipping, and lighting. Direct3D provides a highly optimized software-only implementation of the full 3D pipeline, blah, blah, blah. Let me say it again. 1996, February. This allows for hardware decompressed motion video mapping, hardware 3D rendering in 2D overlay planes. Even so, for example, Direct3D is set the standard for hardware acceleration, including geometry, floating point calculations, transformations, 3D clipping, lighting, also floating point calculations, and rendering, of course. So this defined the market for chips that did not exist, that were general-purpose 3D graphics processors that didn't just draw bitmaps on a screen, but actually accelerated general-purpose mathematics. So it was the rendermorphics people's vision for hardware drivers that if Microsoft standardized a driver architecture that encouraged hardware companies to go from just copying bitmaps around in memory, which is all a video card really did back then, to being general purpose computers capable of general purpose floating point matrix calculations across lots and lots of pixels all at once, and that implied tremendous parallelism, then that would create out of nothing a market for general purpose programmable GPUs or processors that transformed from being dumb graphics chips to computers. So there it is in the doc. So, and this standard, this specification, Microsoft went to ATI and Matrox and S3 and all the Voodoo and all those guys, 3DFX, all the guys who were making chips at the time, and said, here, this is the standard driver model that proprietary Windows operating system is going to support. And we're going to make test suites for it, and only drivers and hardware that support it will be shipped by Microsoft's monopoly on PC OEMs. So if you don't figure out how to make 3D chips that work like this, instead of the proprietary stuff you guys are trying to do so you can get in a patent war with each other, Microsoft's not going to support any of you. You can all die on the vine. And Nvidia was one of the companies that first chose to die on the vine. So the thing was that's kind of not said in the 3D world is that these companies were competing with each other. And the reason they were making wacky and very inconsistent 3D hardware, one, it was a pioneering time. That's definitely true. Don't get me wrong. But it was also that they wanted to be proprietary so they could have little patent gotchas on each other. So if they could make their own weird 3D architecture, patent it, and then standardize it in the market, anybody who wanted to compete with them would have to pay them license fees. And they were all into that. So they all made sure their hardware was wacky. And we saw that and said, Microsoft is not going to get to be a gaming platform if we let the market unfold that way. So we're going to define a driver standard that says, hey, you do any wacky stuff you like, but Microsoft only supports this. And if you want to compete with each other, we want you to compete not on proprietary, wacky things you decided to patent that you're going to try to get the market to adopt so that the market's fragmented. We want you to go from being primitive bit rasterizers to general purpose processing units. We want you to climb this hierarchy, and we built an entire SDK and driver layers to go from rasterization all the way up to being a general purpose computer effectively for hardware companies to follow. So as soon as we put that document out, that's what we said to these companies. And you know who was first on board? One, it was all the traditional Windows chip makers, Cirrus and S3. Those were the dominant ones back then. They got on board right away. And ATI, who had been with us the whole way along. So when you look back at the history of ATI GPUs, they were making GPUs with lighting, transformation, vector acceleration, floating point calculation from the earliest days that this was standardized. And what caused, so in that era, Nvidia, and I'll link some of these documentations because this is where the revisionist history drives me crazy. It's not really revisionist. That's not what's so irritating about it, because it is true. But they kind of make it nice, right? When it's not, was a little harsher than that. So because the reality is always messier. Nvidia came to Microsoft and said, we've got to deal with Sega. And here's our wacky quad-based 3D chip architecture, and we're going to make PC boards, and we're going to standardize 3D graphics on Windows with our wacky quad-based architecture. And I noticed in some of these documentaries, I'll link some of them below, they say that was something Sega did not like, who was their customer. But that can't be true, because Sega was making video game arcade machines like Virtual Fighter that were quad-based. And it was a very standard part of the Japanese console and arcade business to deliberately make their hardware very obtuse. It was a form of digital rights management. You couldn't steal the game to different hardware. If only their wacky hardware could do it. They could patent it. And also they wanted the hardware, gaming and consumer media hardware, to have a long lifespan in the market. So they deliberately make game consoles really obtuse for developers so that it would take developers the entire life cycle of the console, 5 years, to learn how to make a decent game on it. And so that's the reason that so Nvidia was, kind of a product of, hey, we want it to be proprietary and patentable, and our customer is absolutely making quad-based arcade machines, and so I have trouble believing Sega didn't like that. But what did happen is Nvidia came to Microsoft, and I've told this story before, and said, we're going to do this proprietary thing. And I was in the meeting with Eric Engstrom. We were the ones who had that meeting with Nvidia and Jensen in their earliest days. And Jensen kind of came on strong to Microsoft, which was a big mistake back then. And we said, no, we don't give a damn about your quad-based thing. We're not licensing it. We're not going to support it. You can die. You can go out of business. We're doing Direct 3D, and here's the spec. Here's the document. This document right here. Here you go. If you want to make chips that accelerate like this, if you want to compete in the Windows marketplace, and if you want to ship things on Windows Microsoft OEMs, because HP, Dell, Compaq doesn't ship any hardware on their boxes that we don't certify the drivers for, then you support this. If you want to go do your own wacky thing, you're on your own. And shoo. So we were pretty rude to them in that era. And again, I was young and probably more aggressive than I would be in handling professional business interactions today. But, Microsoft was a pretty arrogant company back then, and we told Nvidia to take the attitude and blow with it. And so now the rest of the story, you hear some various versions of it, but for whatever reason, their Sega deal fell through. And they had some hard financial times, and they came back to us at Microsoft and said, we've had a change of heart. We want to go whole hog on this Direct 3D thing. What do we have to do to be a close partner, to ship on OEMs, to get our drivers certified, to get Microsoft marketing support? And we handed them this document and others like it and said, you make hardware that works like this, and then we'll be happy to promote you. And Jensen said to me, I'm going to do that. We are going to make the best gaming and DirectX hardware anybody's made. And they absolutely busted ass at that. And Microsoft definitely got behind them at that point. So our relationship with Nvidia didn't become really friendly and cooperative, until they'd had this sort of, hey, never mind the whole proprietary thing. We want to go the Windows DirectX route whole hog. We want to just be all over it. And so the first Nvidia chips, they accelerated everything DirectX. And we were happy to have them do it, and we promoted them. We switched from pretending they didn't exist to promoting them. And so that was, to Nvidia's great credit, right? That was, a lot of other companies didn't make that leap. Voodoo's gone, 3DFX is gone, because, they rode that proprietary thing into the ground. And then a lot of the Windows 2D chip companies like S3 and Cirrus, they're not really around and dominant. They didn't make the leap successfully. But ATI, who was there and very aggressive about it early on, they did. So the Nvidia and ATI have been neck and neck on implementing Direct 3D acceleration and leading the market to create the modern era of a GPU side by side, right, from the very earliest days. And then, of course, ATI got acquired by AMD, and so we get these two sort of rival companies that are perpetually locked in competition over very similar chips and capabilities and large segments of the market. And the other thing to remember about the GPU is, when did the Xbox ship? What year did the Xbox ship? So this document's from 1996. That's when Direct 3D was made. Until then, 2D, there was no such thing as a consumer 3D chip in any significant, no market for them yet. It was, a lot of talk and effort, but it wasn't there yet. So 1996. The Xbox, it shipped in 2001. So when did they start building the Xbox, start designing it? Well, it was really 98 and 99, right? So Nvidia had come back to Microsoft by late 96, 97, said, okay, we want to get on the Direct 3D bandwagon. What do we have to do? And then Microsoft decides they're going to make a game console. And who were the two chip contenders to make the first GPUs for the first Xbox, as specified by the DirectX team? The people who made this API were the ones designing the 3D for the Xbox, and later Seamus Blackley and other folks, right? Kate Seekings was there for that, right? So, when they said, hey, we want to make a chip to be on the first Xbox, and Microsoft's going to be the first U.S. console vendor with, Microsoft kind of cash to launch, and your chips better look like this. So ATI and Nvidia really busted their butts to make GPUs in time for the Xbox, which was the first game console to ship a GPU that accelerated lighting, transformation, rendering, and polygon acceleration, all Z buffers and all the other things that we came to associate with GPUs. And Nvidia won the first generation of Xboxes. All subsequent Xboxes and all consoles globally to this day are now ATI based. But Nvidia did win the contract to make the first Xbox. And that was done with a very heavy and competitive bidding with ATI. And the bidding war was over who supported Direct 3D as specified by Microsoft best. So that's where GPUs really come from. That's where they originated. Those are the people who caused it to happen. And then, of course, with the wild success of DirectX, these Microsoft employees got hired by Nvidia and ATI. So they went and joined Nvidia and ATI, and they made CUDA, they made the artificial intelligence chips, they made they made all the more advanced graphic chips and SDKs and so forth. So Nvidia and ATI, as the 3D revolution took off, harvested a lot of the early Microsoft talent who had driven all this. And those folks, a lot of the RenderMorphics folks ended up working at Nvidia, which is awesome for them. CUDA was, what was the guy's name? Now I don't even, what a shame. It was, oh God, he was a very boring guy, which is why I'm terrible with remembering his name. But it was one of the early DirectX team members who started CUDA and ran it for several years at Nvidia. So, they were Microsoft people. So, it was the revolution in gaming at Microsoft that really caused the explosion in chip growth for ATI and Nvidia. And the funny thing is, and I love the way the market does, they kind of do the, oh, shock, artificial intelligence, who knew? Everybody, such a surprise and such a weird revolution. And the thing that should be clear about is all the gaming guys, everybody from the gaming industry and everybody into 3D was into artificial intelligence. We're all Isaac Asimov, iRobot science fiction buffs. So the belief that GPUs were a path to, everybody knew the brain was incredibly parallel, and that Intel-type serial or sequential chip architectures were far removed from the way the kind of massive parallel thought that a human mind engaged in. And that a 3D general-purpose chip was really a physics simulating chip. It simulated the real physics of the world, the parallelism of all things interacting with the environment, and light interacting with the environment in real time. So the idea that GPUs would evolve to be incredibly powerful chips that were incredibly useful for AI, everybody planned. Everybody knew that. We go, yes, that's it. We're going to make chips that don't suck at artificial intelligence like Intel chips do. So from the very beginning, the people who pioneered 3D graphics were physicists, and they were fascinated by robots and artificial intelligence, and they wanted computers that could achieve the kind of performance and computational ability to simulate physics the way the real world does. And so that revolution, in some sense, is not a surprise, and especially not a surprise to anybody in NVIDIA. The AI buffs have been there for decades trying to get it there. And as I said in previous episodes, the AI revolution, it's again, you see this sort of revisionist nonsense in the press. We're like, it's Google Transformers changed everything. Or there was some great intellectual breakthrough. And it's not that there haven't been insights and innovations in AI over the years. That is certainly true. But what has absolutely changed is just massive exponential growth and collapse in cost of sheer parallel computing power due to a multi-$100 billion consumer gaming market. So scientists and physicists would never have had the kind of, and Marvel Studios and Weta, Lord of the Rings, right? would never have had the computational ability to produce the kind of movies and do the kind of science we take for granted today if 100 million teenagers weren't buying these supercomputing physics chips to waste time playing games on, right? It fueled this entire economy. And the funny thing about AI that really occurred is that the problem with AI, which is Nvidia was into and everybody was into for many years, and trying to use GPUs for artificial intelligence from the second CUDA was made, and run neural networks on it. And it was the same problem with ray tracing, right? Which is we knew ray tracing was a more accurate model of lighting and physics, that the kind of 3D graphics we had built the first generation of GPUs for were toys. It was cute for the kids to play games on, but they weren't really a realistic model of physics lighting. They were kind of comic book 3D, if you will. So the real holy grail was getting to a GPU that could ray trace. And a GPU that can ray trace is a GPU that supports incredible parallelism and branching necessary to much more complex physical calculations. So the era of artificial intelligence really didn't come about until there was a major problem, which is the volume of data, the amount of information it took to train an AI model was huge. And GPUs were bus bound. They were I/O bound. So the GPU was sort of marooned on this island of near, hyperspace kind of computing speed, sucking data through the slow, pokey PCI bus and a slow serial Intel CPU to try to get enough data in to train anything on. So for many years in the mid-2000s, GPU supercomputing was severely stymied by the inability because the GPUs were terribly I/O bound. And two things changed that. So I had left the game industry in early 2000 and moved to New Zealand and founded a supercomputing company where I was advising some of the world's biggest science projects on how to build GPU supercomputers. And there were two major problems with it. One, the freaking GPUs were I/O bound. So when you get to these large-scale climate simulations and physics simulations, what you would find is the GPU was just overpowered in computing power and just slow as hell at I/O. Because the fastest Nvidia GPU, a home desktop one, could move data over a PCI bus was about 9 gigabytes a second. Right? Whereas a modern GPU can move memory around at terabytes a second, right? It's phenomenally fast. So 9 gigabytes a second is like sucking data through a straw. And yes, I know the PCI bus is supposed to be 15, 16 gigabytes a second, but ATI graphics cards come closer to hitting that. But Nvidia, for some reason, on their desktop chips, just a little I/O bound, just slow. And that hasn't changed over the years, oddly. So I suspect that there's a strategic reason for being that way, which I won't claim to know what it is, or maybe it's a fundamental architecture one. Their laptop chips are faster at memory I/O than their desktop chips are. So the irony is that the same NVIDIA generation chip and an M2 component that plugs into your laptop will have faster bus bandwidth for some reason than it will in a PCI bus in a tower case. Now, it's been a few years since I timed these things, so maybe that's changed, to be fair. But the problem was that when you're trying to build supercomputers and artificial intelligence training systems on GPUs, they were I/O bound. You just couldn't get enough data through them. And so at the time, Cray Supercomputers and SGI and the folks at Weta, I was living in New Zealand, so I was working with the folks. Nereid was funded by the guys who built the Lord of the Rings supercomputer. They were acquired by Microsoft. After they finished rendering the graphics for Lord of the Rings, they spun out as a company, I think, called Green Button, which Microsoft acquired for $110 million. And then those guys funded or invested in Nereid to build these other greater GPU supercomputing clusters, which was my company. And the problem with a supercomputer on something like the Cray back then is that the I/O was highly slow. It was real problematic to get data through it. And NVIDIA had made a special driver for Mellanox network cards, because a Mellanox card over their InfiniBand protocol could move data at 200 gigabits a second over a network. So In that era, about a decade and a half ago, it was the fastest you could possibly move data over a network at almost PCI bus speeds was a Mellanox InfiniBand card. And so, in order for Cray to build supercomputers on GPUs using InfiniBand bandwidths to tie together a big enough computer network, Nvidia had worked with Mellanox to make a special driver that allowed the GPU to drive the Mellanox video card directly InfiniBand via DMA. So, when you plug two cards in your PC motherboard, a gaming graphics card and an InfiniBand network card, usually if you're running Windows or Linux, there's an Intel CPU-based driver mediating communications between them, slowly coordinating, copying data back and forth, and just adding a layer of mud to everything. I get rid of that. And so this coordination layer really slowed them down and made it hard to get the performance. So NVIDIA wrote a GPU driver that ran on the GPU that would talk directly via DMA, as peer-to-peer memory access, to the Mellanox card without needing a CPU driver. And so they could drive that Mellanox card at incredible speeds. Then the problem was getting data in and out of storage, because if the GPU could process data so fast, it needed to get data on and off the card at least 9 to 15 gigabytes a second. And so in that era, I long thought that NVIDIA would put a network port right on the GPU. Just put a frickin' Mellanox chip on the damn GPU right where the video display port would be, plug the network card in, and skip all that garbage. But they never did, which always baffled me. But in that era, I was working on the Square Kilometer Array telescope. And the problem the telescope had was the same problem that they were having in AI. This enormous amount of data that they had to suck in and out of hard drives to process coming from space. And so just the electricity and the cost of processing all this data, they had plenty of computing power. They just couldn't get it in and out of storage cost effectively or fast enough. So I called up NVIDIA and I sent a note to Jensen. And I said, hey, I have an idea. I'm working on the Square Kilometer Array. I would like to get a copy of the Mellanox driver you guys wrote for the InfiniBand for the Mellanox cards, and I'd like to modify it so the GPU can directly read and write to these new generation NVMe drives. Because a hard disk, maybe it could go 150 megabytes a second or 50 megabytes a second, but it couldn't go 12, 20 gigabytes a second. But enough of these NVMe cards could. So the NVMe architecture looks very similar to the Mellanox card. So NVIDIA agreed to give Nereid the source code to their Mellanox cards, and we modified them to be able to talk directly, built a little OS kernel inside the CUDA, in CUDA to run on the GPU, to directly peer-to-peer DMA memory access NVMe cards. And that got the direct NVMe speed up to 9 to 12 gigabytes a second back then per GPU, which was incredibly fast on the local bus. And then you could DMA to the Mellanox card over a network at almost PCI speeds. And now you could use a GPU to do big physics and to do big climate models and to train large AI models. So up until that point, the ability to train or flood a lot of data through a GPU was really problematic. But now you could, and hence, why did NVIDIA buy Mellanox, right? It was because they needed the InfiniBand cards, and Mellanox had incredibly fast storage technology as well. And so Nereid, we gave NVIDIA back the driver for NVMe, and that became NVIDIA's GPU Direct Storage. So if you go look up NVIDIA GPU Direct Storage, that's an API that I made for them at Nereid. And they even used diagrams I sent them to explain the architecture to this day on the website. And that became, NVIDIA licensed it to Microsoft, and that's direct storage in Windows 11 and on the Xbox. So the GPU's ability to directly DMA access without a slow, clunky Intel processor in the way finally freed it to go AI speeds. And that, combined with the incredible intrinsic parallelism of the GPU, and the increasing investment in more a new generation of types of more less rigidly pipelined uh, um, ray tracing processors, started making the GPU really appealing use for general purpose AI and neural network training. And, yes, then researchers, given infinite cheap computing power and the ability to actually practically train large scale models, they had some ideas that enhanced that as well. But it wasn't a dramatic innovation in training models. Most of the innovations, like Google Transformers, have been incremental. They only improved AI training by speed by about like 3 or 4%, which is good, cool. But Nvidia improved AI training speed by 10,000%. So the sheer horsepower and bringing down the cost of that kind of computing, and figuring out how to solve the bandwidth bottlenecks, is really what led to the modern AI era. So when you see the kind of revisionist, it's just, oh golly, they got lucky and artificial intelligence and Google made Nvidia rich, and that was horseshit. Nvidia and ATI have been positioned and poised and tuning for the AI era to arrive for decades, and so they very systematically well positioned for it. And the funny thing is, then you also get the financial guys going, well, but they're threatened by competition from Tesla and Intel and Google. No, they're not. They're not threatened at all. The Nvidia and ATI graphics architectures. The thing that the problem is, people go, oh, there's AI is like a commodity. You just need lots of these simple processors, and for inferencing, that is for using a trained model. Yeah, you could mass produce or commodify the chip that does the inferencing, or the chips that do the inferencing. But for training models, that's still Wild West learning R&D. And these NVIDIA and ATI GPUs have incredible additional computing capabilities on the graphics side, right? Think about if you're trying to train an AI model or a robot to understand the 3D world. Well, the Unreal Engine and Unity game engines are the most comprehensive simulations of all real-world physics, physical effects, sound, interactions with materials and collision, and the tools to author that anybody has anywhere. So if you want to teach a robot how to walk around or navigate the world, you're going to use something like an Unreal Engine or Unity engine to train it. And only an extremely powerful graphics GPU could do that. So, yes, there'll be a commodification of the chips that use trained AI models. But NVIDIA and ATI, and again, ATI has always baffled me, because they've been happy to let NVIDIA sort of lead, and then they just sort of follow with a lower cost thing. But it's obviously worked very well for them. But in the AI revolution, NVIDIA's been preparing this way for a long time, systematically working on the problems. Everybody working, remember the acquisition of physics. Everybody in the gaming world who does 3D game engines is a physicist, right? They want those computers to learn to have the kind of, capabilities. So when it comes to AI research and building chips that are going to think more like a human brain, well, graphics GPUs are the only ones that actually can literally construct a version of reality that so good that humans believe it, that kids will play in these virtual realities and think it's indistinguishable from their world. That's how good the chip's ability to simulate the kind of reality our brains simulate is. It's an amazing achievement, completely unrelated to neural networking. So I personally, would keep holding on to that NVIDIA and ATI stock, because I don't think there's going to be any competition, serious competition for that. And if anything, the commodification of inference engines will increase the demand for R&D and model training. And so NVIDIA, I think, and ATI are going to keep that lead for a long time. So anyway, to get back to my earlier, point, It was actually Microsoft that deliberately created the modern GPU, and it was Kate's. It was the RenderMorphics people who had the vision for it, which again, we're glad we embraced it. Um, and Microsoft creation of the Xbox that caused an arms race between ATI and Nvidia to accelerate what I just read you, the Direct 3D hardware stack from Direct 3D 1.0 1996, such that as soon as the Xbox shipped in 2001, that was the first GPU that really shipped, right? And well, people point to steps along the way, but effectively, it was the Xbox that created GPUs, which were as driven by ATI and Nvidia vying to meet Microsoft's requirements for that. So I want to point that out just because, for some reason, the history guys just can't get that right. They can't get that. They don't make the, hey, Xbox played a huge role in this. Microsoft kind of told them what they all had to do. Otherwise, they would have just fragmented the market and frankly, all died. Because that was, competition's natural instinct, absent a lot of pretty forceful leadership from Microsoft on that point. So anyway, that's my assessment of, my and I'll post the one of the revisionist history or revised history articles I've seen up there as a reference, because it's good material. It's not like it's wrong. It's just like it misses the story, which is a shame. There's some good stories there, and some interesting history, right? So I have all of the original DirectX SDKs, the betas I made, the documentation, the emails, a lot of the emails from that era. So, I as I get time, it'd be nice to have a file share or so forth. I'll find places to post more of this stuff. But, I don't want it to get lost in the sands of time because it's important history. The era in which computers started coming to life and thinking was driven by gaming, and that's a pretty big idea. It shouldn't get lost there, and the media's inclination to go, it's such a mystery and surprise where AI came from, is irritating and insulting to everybody who's been doing it on purpose for 30 years to get us here. So it is like, oh man, just who knew, or you also get the infallible CEO story, right? Which again, Jensen's brilliant. Do not get me wrong, but you just get Gates and Ballmer and Mark Zuckerberg and Elon Musk. They just never effed up. They never did a stupid thing in their lives. They never do a stupid thing now, right? They never say anything dumb now. They never make a business mistake. So, you sort of, when those of us who watch the news, you go, well, you see that, but it's interesting watching over time how the PR and the media kind of smooth all that out so that all the next generation remembers is that their meteoric success of billionaires was completely thought out, managed, controlled by great genius minds, when in fact there was a lot of organic competition that got them there. So anyway, with that, I'm going to sign out. Hopefully we'll get some STS parts in here, steal the show parts in here, and we will build our streaming media server for TwitchCon before your eyes. In the meantime, I'll keep telling old-timey stories and stuff. So you guys have a good evening, and hopefully I'll see you soon.